measurement and algebra. Revisiting the Pythagorean theorem. The Pythagorean theorem tells us that the square of the side opposite the right angle, this one here, this side, is called the hypotenuse, and it equals the sum of the squares of the other two sides, which is kind of wordy. What that tells us is side C, right here, when I square it, I get C squared is equal to this side here, A squared, plus this side here, B squared. Okay. Things to remember, the hypotenuse is always opposite the right angle. It's always the longest side, and it always stands alone in the equation C squared equals A squared plus B squared. And by stands alone, I mean it's always the one that's on the side of the equal sign by itself. Now, if I look at each of the following triangles, they're all right triangles, so they will all have a hypotenuse, okay? And when I draw a line straight across from my right angle, that side that I've drawn my line across to is always going to be my hypotenuse. Now, the question asks us to label the hypotenuse and state the equation that can relate the three sides of each triangle. So it's very straightforward. In part A, B is the hypotenuse, so we write B squared is A squared plus B squared. So we square each side. B is the hypotenuse, it's the one that stands alone. In part B, A is the side that stands alone, so it's A squared is B squared plus C squared. In part C, side F stands alone, so we'll write F squared is A squared plus C squared. And in part D, A is also the side that, A is the side that stands alone. It's the hypotenuse opposite the right angle, so we write A squared equals B squared plus C squared. And that's written neatly on this page for you to copy it into your notes later on. Things to remember about the Pythagorean theorem is it can only be used if the triangle is a right-angled triangle. So when you draw the triangle, you have to see that symbol there to indicate it's a right-angled triangle. And the other thing to remember is it's used to find the third side, and you have to know two sides in order to use it. Example 1 says, solve for the missing side, correct to one decimal place where necessary. Get our handy-dandy pen out. We've already used our handy-dandy highlighter, and it asks us to solve for the missing side. If I look at part A, I see a right triangle, so I know I can use the Pythagorean theorem. Okay, so I'm going to look for my right angle, draw a line straight across, and X is my hypotenuse. So it stands alone, and I start with X squared equals. Now I'm going to take each of the other two sides and square them. So what do I substitute in? One side is 3, the other side is 4. And my good friend BEDMath always takes control in math. And I have to do the exponents before I do the addition. So 3 squared is 9, 4 squared is 16. So X squared is 25. And I have to take the square root of both sides to solve for X. And X is in fact 5 centimeters. And at this point, I'll put the units back in because the question gave me side length using units. In part B, again, I'm looking for side W. And I need to, it's a right angled triangle, so I can use the Pythagorean theorem, find my right angle, draw a line right across, and the side that stands alone is the 7. Not the W, it's the 7. So I write 7 squared equals 6 squared plus W squared. The math takes control. I've got to simplify everything as much as I can first. So 49 is 36 plus W squared. And I need to subtract 36 from both sides in order to get W by itself. Remember, we needed to make 36 on the right side go away. And if I subtracted on the right to keep the equation balanced, I had to do it the same thing on the left. So now I end up with 13 is W squared. And in order to solve that, I need to take the square root of both sides. So I'm left with root 13 on the left and W on the right. And it said to correct to one decimal place. So when I square root W on my calculator, I get approximately 3.605, 516, and it said to one decimal place. So I need to look at my graph, and I want to round to this space, not at my graph, sorry, at my number. I'm being distracted in the background. I'm going to underline the 6. Look at the number to the right. It's a 0. Since that number is less than 5, I leave the 6 alone, and I write approximately 3.6. Notice that once I started putting rounded numbers, I put a dot above my equal sign. Last thing I want to do is do a word problem. So example 2 is talking about a surveyor. It says a surveyor is finding the height of a vertical cliff. She measures the base of the cliff to be 100 meters away and the top of the cliff to be 125 meters away. Determine the height of the cliff. I don't need to highlight the word surveyor because I don't care who's doing it. I care that it's the height of a vertical cliff that she's measuring. Oops. The next sentence tells us she measures the base of the cliff to be 100 meters away. The top is 125 meters away. Determine the height of the cliff. So what am I looking for? I'm ultimately looking for the height of the cliff. So the height of the cliff is going to look like that. It's going to make a 90-degree angle with the ground. I know that the base of the cliff is 100 meters away from where the person's standing, so let's draw the person standing over here, and that's 100 meters away, and it says the top of the cliff is 125 meters. So we're going to put the 125 right here, and we need the height of the cliff, so I'm going to put an H for height. So we need to write a let statement. Let H represent the height of the cliff in meters. Now, we have to look at that. It's a right-angled triangle. We have 2 side lengths we know, and we're looking for a 3rd side length. What can we use to solve something like that? We can use the Pythagorean theorem. So I need to locate my hypotenuse first. And my hypotenuse is always opposite the right angle. So the side that stands alone is the 125, and I have to square it. And that's going to be equal to the height of the cliff squared and the 100 squared. And then if we use our handy-dandy calculator, we get 15,625 is 10,000 plus H squared. And I need to get the 10,000 to move from the right side of my equation to the left side. And I do that by subtracting it from both sides of the equation. And then, in order to get the height, I have to figure out the square root of 5,625, which I'm just going to cheat and turn the screen to the next page, and that's 75 meters. And we can write the therefore statement, therefore the cliff is 75 meters high. We didn't have to put any dots above the equal sign because none of those were rounded numbers. They were all exact. And we don't have to use the word approximately in our sentence answer because, again, it's an exact value. And before class tomorrow, please do pages 3 to 4, Pythagorean theorem questions 1 to 2 and 3.